Okay, so we are going to be looking at solving quadratic inequalities. So this isn't a specific section in the book, but they briefly cover it, and I just felt like they didn't go into enough detail. So today is just about getting extra practice. So we'll first kind of take a look at this, take notes, and then your homework will just be practicing this. So I put together some steps that I feel like might be helpful. So I will allow you guys to pause this if you guys want to write those down. I'm also going to be posting this, but we'll go ahead and get started with our first example, and we're going to use those steps. So the first thing that we want to do is set the inequality equal to 0. So I'm going to remember that inequality sign, so I'm going to keep it there, but I'm just going to kind of treat this like an equation. The next thing that we're going to do is factor if possible, because what we're essentially trying to do is find those x-intercepts. So I need two numbers that multiply to 3 but add to 4. So that would be x plus 1 and x plus 3. And remember, this is equal to 0. And then it says to set each factor, I should have said equal to 0 to obtain the critical numbers. So that is what we just did. So our critical numbers would be x equals -1 and x equals -3. So what we want to do next is place these critical numbers on a number line. So I have -1, and I know that they're going to be solid dots just because of the fact that it's equal to. I'm going to redo this here. So we'll have -3, -2, -1, 0, 1. Just have a few on there. So I have -3 and -1. So what we want to do is test points in the regions. So we have 3 different areas we need to test, right here, here, and here. So we'll first go ahead and test on the left, and that's where it says use interval notation. So I'm going to plug in -4 and see if it makes the inequality true. So we would have -4 squared plus 4 times -4 plus 3, and we want to know, is that less than or equal to 0? So this turns into 16, and then -16 plus 3. So we have 0, essentially, plus 3. So is 3 less than or equal to 0? No. So that doesn't make it true. So in this case, we can kind of guess what will happen, but we're still going to plug in points just to be sure. So let's go ahead and plug in something in the middle. So I'm going to plug in -2. So -2 squared plus 4 times -2 plus 3 is less than or equal to 0. So we would have 4, and then -8 plus 3 is less than or equal to 0. So 4 minus 8 is -4, plus 3 is -1. So is -1 less than or equal to 0? Yes, so that's true. And then lastly, we'll test that last point, which will be pretty easy because I'm going to plug in 0. So 0 squared plus 4 times 0 plus 3 is less than or equal to 0. So those cancel. So is 0 greater than or equal to 3? No. And we can probably guess that that would have happened because it's either going to be both on the outside of those critical points or that in between point. So the last thing that we would do is just write our solution in interval notation. So the solution is going to be in between -3 and 1. So this is how we would write it. So the most important thing is finding those critical points, because without those, we don't know where the solution will be. From there, the testing part is pretty easy, and I did more than I really needed to. So let's go ahead and just do one more example to kind of give you guys a head start so you're ready for your assignment. So we have 5x squared plus 10 is just greater than 27x. Okay, so the first thing that we will do is move everything equal to 0. So we would have 5x squared, and this would be minus 27x plus 10 equals 0. Okay, then I'm going to go ahead and factor this. So I'm going to go ahead and use the box method just because something that I feel comfortable with. So I have 5x squared and 10. So I know that I'm looking for two numbers that multiply to 50x squared but add to negative 27x. So I have 10 and 5, 25 and 2. So negative 25 and negative 2x are my winners. So those will go here. So this would have to be x, 5x. This will be negative 5, and this would have to be negative 2. So my factors are x minus 5 and 5x minus 2. I set those equal to 0, and I'm solving for them so I can find my critical numbers. So my critical numbers would be 5, and my other critical number would be 2/5. And then from there, this is where we would want to go ahead and plug in points to do our interval testing. So I'm going to go ahead and set up a number line. So I have 0, 1, 2, 3, 4, and 5. So I'm going to go ahead and put a dot at 5. And then 2/5 is going to be less than 1. So in between 0 and 1, but less than 1. And then I'm going to go ahead and start testing the numbers. So I will pick a number like 0, for example. So if I put in 0, I have 5 times 0 squared minus 27 times 0 plus 10. And this would all be greater than 0. So we want to know if that's true. So we would have basically is 10 greater than 0, and that is true. So 10 is greater than 0, so this means that over here it's true, so we can guess that this would not be true. And just to verify, we'll plug in 6 to make sure. So we have 5 times 6 squared minus 27 times 6 plus 10, and we want to know that if that's greater than 0. So looking at this, 6 squared is 36. So we have 5 times 36. And then we have 27 times 6, which is 162 plus 10. We want to know if this is greater than 0. So we just have to do 5 times 36, which is 180. And then we would subtract 162 and then subtract 10. And we get 8. So 8 is greater than 0, which means this is true on the outside. So how we would write our inequality this time, since the original problem just had a less than or greater than symbol, we would do x is less than 2/5, and we would do or x is greater than 5. So this should give you a good idea of how to solve these quadratic inequalities.